All right, so for this video, I'm just going to run through examples of literal equations and try to give you quite a few situations where you would need to solve and just kind of work through several different scenarios. So again, I'm going to make sure that I circled the variable that I'm solving for. So it says solve the following equation for b. So I'm going to circle for b. So that means I want to get b by itself. So I'm going to rearrange this by doing inverse operations. So I have b times h, or h times b, same thing, equals 5. So if it's times, I'm going to divide by h. So when I rearrange this, b now equals 5 divided by h. All right, for the next one, it says the following equation, we're solving for a this time. So if we're solving for a, I have a plus d equals j. So a plus d, we need to move that d variable over. So if I have plus d, we're going to subtract d. So now I have a equals j minus d. All right, so for the next one, I'm solving for r. So if I'm solving for r, I have d equals rt, which means r times t. So we're going to undo that multiplication by dividing by t. Okay, so I now have r equals d divided by t. Now the next one is not hard, but a lot of students will try to make it work in the way that they think it should instead of doing the inverse operations. So when I look at this problem, I'm being asked to solve for r. So a lot of students will try to think, okay, I need to get r by itself, so I need to get rid of v, and they'll multiply by v. But right now, the r is in the denominator. I have to get that r out of the denominator in order to solve for it. So if I multiply by r on both sides, just like I would if it was any other variable or number, that's going to move it to the left. So I have ri equals v. And I'm still solving for r. So if I have r times I, and I'm going to divide here by I, because inverse of multiplication is division, I now have r equals v divided by I. So if you ever have a variable in the denominator that you need to actually solve for, you need to multiply and get it out of that denominator first. All right, so for the next one, I have solve for b. So this time the b is in the numerator. So we need to get rid of that denominator of 2. So we're going to multiply by 2 on both sides. And that's going to cancel the 2's on the right. So I have 2a equals b times h. And again, we're solving for b. And I have b times h. So I'm going to divide by h now because that's the inverse operation. So b equals 2a divided by h. So these same rules apply. I'm still doing the same things that I would do if I were solving an equation to get an actual value, except for this time I'm using the same rules to rearrange. All right, so for the next problem, we are solving for d. So we're going to solve for d here. Now, in order to solve for d, that means that we need to get rid of that denominator of n. So we're going to multiply by n to get d by itself. Now, here's the thing. The whole left side, or excuse me, the whole right side has to be multiplied by n. You can't just pick and choose what you want n to be multiplied by. So I'm going to use parentheses in order to make sure I'm multiplying the whole right side by n. So d equals n times, with the parentheses to make sure I'm multiplying the whole thing, g plus h squared. And that problem really only took one step. It looked like a lot, but we were solving for d, we did the multiplication, and we're done. All right, for the next problem. For the next problem, they're asking us to solve for a. So in this problem, we have a, but this time a is in the parentheses. So I've got to get rid of that parentheses in order to actually solve for a. Now, when we were solving for equations, the first thing we would have done is we would have distributed the g into each part. So we've done g times a and g times h. I'm actually going to not do that, and I'm going to simplify this. I know that g is being multiplied by the whole parentheses. So I can divide the whole problem by g, because multiplication, the inverse is division. So if I divide that whole problem by g, That leaves me with the parentheses left over. So G plus H equals M divided by G. I'm still solving for A. So in order to do that, I'm going to subtract my H here. And when I subtract my H, that gives me my A value by itself. So I have M divided by G minus H on the outside by itself. All right, so for the next one, we're solving for A again. And A is on the outside of the parentheses. So this is very similar to the one we just did, except for it looks like it's a lot more than it actually is. A is being multiplied by the whole parentheses. So if I want to get A by itself, I can divide by the whole parentheses because the whole parentheses is being multiplied. And the opposite of multiplication is division. So I can divide by that whole parentheses. So A equals 4n over h squared plus m. Again, it looked like it was a lot more than it actually was. But you have to remember, if you have multiplication, if there's a parentheses there, make your life a little bit simpler and go ahead and divide by that whole parentheses. Now, if you're solving for something in the parentheses, then you're probably going to have to make sure you evaluate it before you really just jump in and divide. All right, so for the next one, we're solving for A. Now, this one has a fraction in there. And a lot of students don't seem to normally like fractions when it comes to these types of problems. But I'm going to show you an easy way to handle fractions. We are going to multiply, and we're going to multiply by the reciprocal. Now, the reciprocal is simply, if I have 1/3, the reciprocal is the opposite, which is 3 over 1. If I have 2/3, then my reciprocal is 3 over 2. So the reciprocal is where you flip the fraction. So I'm going to multiply by 3 over 1, or just 3, to get rid of that fraction. Why did I do that? Because now the 1s are going to cancel, the 3s are going to cancel. And that leaves me with d cubed times a equals 3b. B times 3 over 1 is just 3b. We are still solving for a. And I have d to the 3rd power times a. So if it's times, that means we're going to divide. So a is going to equal 3b divided by d cubed. Now, I believe we just did this problem, which we did. So I'm going to skip this problem right here. All right, so the next one says to solve for a. So if I'm solving for a, remember we talked about this just a second ago, that a is in the denominator, so we're going to need to get that a out of the denominator. Now, with this type of problem, I would go ahead and what we do is cross multiply. You cross multiply when you have an equal sign and you have those fraction values. So I'm going to cross multiply here. So I have n times a and r times b. And since I'm solving for a, I can now have n times a, so we're going to divide by n. And a equals rb divided by n. All right, please pay close attention to this one because we're going to talk about a GCF in this problem. And the reason we're going to have to talk about a GCF because we're solving for a. But if you notice in this one, we have 2 a's in this problem. We can't solve for one of them until we only have one of them. So I should be able to recognize that we have what we call a greatest common factor, a GCF. So if I have a greatest common factor, I can take that out of my problem like it was multiplication. I could undo basically the distributive property. Okay? So it's kind of like me taking the a's back out. I'm going to take them back out of the problem that I multiplied it in originally. And in doing that, I now have 1a. So now that I have 1a, I can solve for that a value. In order to solve for that, I have a times this whole parentheses. So since I have a times the whole parentheses, I'm going to divide by the whole parentheses. And then since I divided by the whole parentheses, it's gone on the left-hand side. And I now have b divided by 2m cubed minus n for a. All right, last slide. So it asked me to solve for f here. So if I'm solving for f, f is in the parentheses. Again, this is one of those situations where I have a parentheses. A lot of students try to go ahead and distribute 5 over 9. But when you distribute the 5 over 9, you're just creating a bigger mess than what you need to begin with. So I'm going to refer you back to the multiplying by the reciprocal. So we have 5 over 9. So if I have 5 over 9, we're going to multiply by 9 over 5. So on this side, I'm going to multiply by 9 over 5. And I'm going to multiply this side by 9 over 5. And again, the reason I wanted to do that was because my 9s and my 5s are going to cancel out because I have one in the top, one in the bottom. So I now have 9 over 5c, and I no longer have a parentheses, I just have f minus 32. And since I have f minus 32, I'm still solving for f here. So I'm going to add 32 to the other side of my equal sign. And that gives me 9 over 5c plus 32 equals f. Now, the last problem is probably the most common literal equation that you're going to use. This is a linear equation. It's in standard form. But a lot of times when we're using standard form equations, we need to put it into slope-intercept. So we would need to solve for y. So we're going to practice that skill here with a literal equation. Now, this minus 4 is attached to the y because it's negative 4 times y. So we want to take the whole term, 3x, and we want to move that whole term. Well, the way that we move it is it's positive here, so we're going to subtract 3x to the other side. All right, so I'm going to bring down my negative 4y. Now, I like to put my x first, just because if I'm solving for y, you're basically putting it in the slope-intercept, which is y equals mx plus b. And that x term is normally first. You don't have to do this, but it's just a habit to get into, so that when you do get to linear equations, it becomes like second nature. So I'm going to do negative 3x, and that's a positive 12, so plus 12. All right, so right here I'm still solving for y. So I'm going to divide by negative 4. Now, at this point, I could potentially leave it like this, but I am going to teach you to simplify. And the reason I'm going to teach you to simplify is because you're going to have to do it when you get to linear equations. And the way that you simplify is you're going to divide both pieces in the numerator by negative 4. So negative 3 divided by negative 4 turns into positive 3 over 4x. 12 divided by negative 4 is going to be minus 3. And there's my simplified version of y equals mx plus b when you solve for y. Again, literal equations is simply rearranging. Use the same tools that you would if you were solving to get a value. You do your inverse operations.